today we're going to quickly cover a little bit of background just so you know who the Microbit Educational Foundation are. We're going to do our very first steps in some coding, so if you haven't done it at all before, this is perfect. If you have, then you will be cooking on gas, but we'll cover all of that. We'll look at a little bit of inspiration and ideas, and I'll finish off with what the support and resources are that are available, and maybe just touch on what we'll be covering in tomorrow's session. So the Microbit Educational Foundation is a non-profit organisation. So we started in 2016 after the BBC Make It Digital project. So it was a big project where there was a rollout of BBC Microbits, and there was also a kind of roadshow tour around some cities. So I remember going to the one in Dundee, and there was Daleks and all sorts of things at the roadshow. We are a very small organisation, but how we work and how we collaborate is how we get the phenomenal reach that we have. So we work with amazing people like Education Scotland, but other education partners, community outreach, governments, technology groups, all working together to achieve our mission. And what's really important to us is that it's about access for everyone. So we do have a particular focus on underrepresented groups and girls as an area where often don't have the equity of access, but we all work together towards our goal, which is to inspire every child to create their best digital future. And there's some nice, happy, smiley faces. So everyone in Scotland, it's great talking to Scotland because every school in Scotland will have received a box of 20. So if you haven't opened your box yet, or you've opened the box and you're a little bit intimidated, we'll have a quick cover of what's in the box. So there is the tiny computer. So the thing in the middle of the screen is the Microbit. So that's a computer, it fits in the palm of your hand, and it's got open circuits on the back. So I'll show you on a later slide, but what's great about it is you can hand it to your young learners and they can have a look. For me, I have to have a look with glasses, but they should be able to see all the different components labelled up on the back, so they get a sense of actually it's not just a mysterious box. These are all the bits and pieces that go into this computer. There's also a data lead, which is one of the ways that you can put your code onto your Microbit. And then there's a battery pack. So this provides the power so that you can disconnect from the computer and you can take whatever you've made to the playground, to a different classroom, to the field, down to the beach, whatever you're doing, whatever your program is for. If it's for mindful breathing, you can be sitting under a lovely tree with sunlight dappling through. If you're doing some data logging and you're doing a traffic survey outside your school, you can take it and you can sit on the bench by the school gates and you can do your traffic survey. So it allows you to take it away from the screen to be able to do things, and also build it, Blue Peter style, into badges and boxes and all sorts of creative things. Also inside the box that you will have received with your donation was a poster. Now, the poster tends to be folded up with just some jazzy words and symbols. There's a few different variations. I've got one that says, "What will you create?" People don't always seem to have noticed on the back of that poster. It's a double-sided poster. It has also got, this is half of the poster on the screen at the moment. It's got both sides of the Microbit all labelled up, which is a great thing to have up on your wall. Digital is often difficult to represent on our classroom walls. So this is a great way to kind of show all the different things that this tiny, tiny computer can do. And it labels it up as inputs and outputs. So it's got the buttons here and the LED lights, and the fact that, with the version 2, the logo at the top now is a button. And on the back, it shows you, where the processor is, the accelerometer, the radio antennae, and all of those bits and pieces. So just wanted to point that out. The other thing that comes up as a kind of frequently asked question is sometimes at this time of year you might have inherited a new classroom. You've had a look in the cupboard, you've found some Microbits, you're not quite sure. So there are 2 versions of the Microbit, and the easiest way to tell the difference is if you look at the Microbit, if it's got a flat bottom, it's a version 1. So a flat bottom, straight line at the bottom. I try and remember it because it looks like the shape of a number 1. That's a version 1. So the version 1 doesn't have the touch button on the front. It doesn't have a built-in speaker, and it doesn't have the capacity to do the data logging and record the data onto the device. The version 2 has a bumpy bottom. I can't believe I'm talking about bottoms, but the bottom of the device is got little indentations, and that's the one that has the speaker and the touch button and stuff like that. Now, in terms of the speaker, that doesn't mean that if you're mixing up between version 1s and version 2s, always with version 1, you can use the pins at the bottom to connect up with some crocodile clips to some headphones. So you can still do sound things there. And if you've got, you'll see the pins along the bottom. If you've ever used anything like Makey Makey, similar idea. The pins at the bottom just allow you to make all sorts of different circuits to look at conductivity and explore all sorts of things like that. But let's keep going. So I'm going to show you a very quick intro video, and then we're going to get started on some coding.
It's really simple to get started with the BBC Microbit. You just need a microbit, a micro USB cable, and a computer. The microbit is a piece of hardware, a tiny pocket-sized computer. To make it work, you have to tell it what to do by writing a computer program. Programs are called software. The micro USB cable is used to transfer the program onto the microbit. Let's have a look at it. On one side of the microbit, you will see 25 LEDs arranged as a square to make a simple display. There are also 2 input buttons, button A and button B. On the other side, you will see a reset button and a small socket to plug in a battery pack. We explore the processor and other features in further videos in this series. A microbit can only do what you tell it to do, so the first thing you need to do is write a program. You can use different programming languages to do this. For example, MakeCode, which works as a block and text editor, or the Python text-based editor. For beginners, MakeCode is a good place to start. We've selected some simple projects to help you. Choose one to get started. The latest version of the microbit has some exciting new features. The microphone adds a sound sensor, and the special LED on the front of the microbit lights up to show you when this new sound input is measuring sound levels. The speaker lets you add sound as an instant audio output to your projects. On the front of the new microbit, its logo is now gold. This new capacitive touch sensor is an input that helps you interact with your microbit in even more exciting ways. And now you can turn the new microbit off by holding your finger down on the reset button on the back, and you can wake it up by pressing it again.
So there we go.
It's really
I don't want to do that. So that is one of the videos. Those videos are on the Microbit website. So that's the intro one. There's also videos to explain some of the different features, like the accelerometer and things like that. So they're great for sharing with your young learners if you are wanting to start and explore certain features of the Microbit. So first thing we're going to do is we're going to start getting some coding on. So if you want to code along with us, then you are very welcome to. I am going to try and I'm just going to try and I want to shrink that down. So we're going to go to MakeCode. So that is makecode.microbit.org. If you don't want to code along with us, that's absolutely fine, but just giving you the option. When you come to MakeCode, it always looks like that. Now, the great thing with MakeCode is that you don't need to have an account. So sometimes when you're doing coding, particularly with young learners, you've got the admin of setting up the accounts and then the invariable, I can't remember what my password is, miss. Don't need to worry about that at all with MakeCode. It doesn't require any accounts. You make a new project, and then what you do afterwards, if you want to keep a record of the code, they will be able to take a download of what they've made and store it on however else you might store things within your school. So they might have a class drive or a space on class drive or OneDrive or a plug-in memory stick. So just however you would normally do it. So when you come to MakeCode, you're just going to press New Project, and you're going to give it a name. I'm going to call it Webinar, but you give it a name of whatever you're going to make. Now, the first thing that we're going to make today is, so if any of you did any coding when you were a little bit younger than you are now, probably one of the first things that you did was print to the screen, "Hello World." Don't know why, just that was how everybody first learned to code, particularly text-based. First way that most people tend to learn how to code with Microbit is to make a flashing heart. And quite frankly, after the few years we've had, the more hearts flashing and love we have in the world, the better. So that's what we're going to do. But I'm just going to give you a quick overview of the MakeCode platform at the moment. So every time you start, there's always these two blocks there. On start does what it says in the tin. That's things that will happen on the start of the program at the beginning. So that might be initializing variables, it might be a welcome message, could be something like that. And a forever, again, does what it says, it does something forever. So that's an infinite loop, so it might be something flashing.
Lorna, sorry, can I just ask, could you zoom in a wee bit if that's okay?
Yes.
Thank you so much.
Yeah, there we go. Is that helpful? Is that better?
That's much better.
Is that much better? I just realised I'm on a giant screen, and sometimes it's better to share the smaller screen because it doesn't like. Anyway, right. So if you've used Scratch before, very, very similar way to code. So it's in fact just the inverse. So we've got the big space where we're building our code here on the right. We've got our Sweetie Shop picking mix selection of options that we can use. So if we have music, we click in there, we get all sorts of options. We can drag and drop and move them over. And then on the left-hand side, that's our simulator. So even if you don't have microbits, or you have enough microbits for one per child in your class, they can still do lots of coding, test it out. It's a great way to kind of test, iterate, reflect on what they've made before it's downloaded to the device. So simulator, very well used. What we're going to do first, though, is we're going to get our flashing heart going. So we don't need on start. So just like Scratch, we can just throw it away and we can tidy it up. And we're going to do something forever. And we're going to go to basic. Basic gives us all sorts of different options. Now we can draw pictures on our LED screens here, but I can already see that there's already an icon called heart. So I'm going to just drag, click that in there, and you can already see that the simulator is instantly updated with what we've got. So I've got a nice big heart there. I am going to have a look and see, well, do I have let me see what else I could put in here. I have a small heart, and all I'm going to do is go back and I'm going to find the pause. Now the pause, the tricky thing about the pause, which is, it tells you when you click on it, it's in milliseconds. So it's just another learning opportunity when you can talk about, what is, half a second, 500 milliseconds. So I am going to make that 2 milliseconds, and I'm going to put another one in so I can get a nice rhythmic thing. So it's going to take a second on the left-hand side, and now I've got a lovely beating heart. And that most typically is the very first program that most people make for their microbit. And it's a lovely one, and it's got, 4 or 5 lines of code. And you've already got a little animation, and you could extend that animation, or you can make it, animals move, different things happen in and around there. I just heard, were you going to say something, Louise? No, I thought I heard
for me, sorry,
just, there we go. Okay, so what we could do after that is I'm going to let me just grab this and put that back over there. So I'm not going to share my screen because I'm going to move back and forward, so I'm going to make that as big as possible. So I'm going to ask you a question. I'm going to see if I can find the chat facility, and I'm going to ask you to have a look. We've got the zooming in, perfect, Brian. So let's extend what we've done. So on the left-hand side is the bit of code that we've just made together. Okay, the pause is a little bit different length because I changed that, but essentially it's the same. What's different? What's new about the code on the right-hand side? Can anybody unmute or pop it in the chat? We'll see what we can find. See who's the first brave person.
It will start when button A is pressed.
Absolutely. Brilliant. Thank you. So yes, so it's not the forever anymore, Mr. Armstrong, you're absolutely right. And now it happens on a command. Yes, it happens on an input. So if you press button A, that will happen. So that's great. So that's another great way, particularly if you've got younger learners, to build in some of those concepts, is to get them to do a bit of spot the difference and identify, okay, you've almost got the same code, what's different about that? If you can go to the link there, which is mbit.io /pd-explore, then there is another way I would like you to look at. It should take you to a page that looks like this. Now this is one way that you could share some code out with people in your class. So when you get taken to a page like this, you're able to press edit so you can change things. I've got a bit of feedback, I think. You're able to drop a whole load of blocks, as many blocks as you want, in there, and so you could say to your class, okay, I've got a beating heart that happens on button A. I'd like to have a smiley face and a sad face rotate or go in a loop if I press button B. And you've scaffolded them by giving them the blocks. So they don't have to go off and search and find them, and then they can start to do that. And if I do this here, I've just taken an edited version. You can be doing your own changes, so everybody can be working independently. So we will look at Google Classroom, which works in a little kind of similar but different because you can see everybody. But this is another way that I know a lot of teachers like to share a bit of code, a bit of scaffolded code. So here's the Lego bricks I want you to use. I'm going to set you a challenge, have an explore, have a play, and take it forward. And it basically, you build the things you want. If I wanted to make a new one that had some music notes in it as well, and maybe some, I don't know what other random thing I could add in there, a show LEDs, I can just go up to here. I can share the project. I can call it something. I can press the share button, and it'll give me a URL to then share out that I could put on Teams or Classroom or put on the board or whatever I wanted to do, email out to my class. So just showing you that way that we can scaffold some of the learning. And yes, Microbit Classroom is what we're looking for tomorrow, but I did say you could share the link through Google Classroom. So there's an awful lot of Classroom chat. Apologies for that. So that was a challenge, so you can have a look at that challenge if you would like, and then let me swap that round. So we've got the presentation as well, and then one of the other, so that was the extension, we've done that, and then one of the other first projects that typically happens with the Microbit from speaking to teachers is just in and around the input. So, the inputs and the outputs are what makes the Microbit really powerful. So the ability to take a bit of information from the user. So it could be pressing button A, pressing button B. It's got an accelerometer, so it could be shaking it, all sorts of different inputs from the sensors, like a light sensor, temperature, that kind of stuff. So taking one of those and causing something to happen as an output. So one of the first projects, which again, there's a link there if you want to have a look and explore, is just, giving them two buttons, press button A, press button B, and then have something happen for each of them. So it might be a happy and a sad face. It might be, it might be a different animal. Yep, happy to share the slide presentation afterwards, Mrs. Marley. And then getting them to download, put it onto their device. So we'll look at downloading in just a second, and then exploring between, I said this would happen for button A. Can I test it? It does. The great thing, which I missed completely here on MakeCode, is you can actually do the testing on the simulator as well. So I could press button A there, and it will start the heart thing. And if I was to very quickly just drag that code in here, just to prove that it actually works, then if I were to press button B, I would get a fluctuating sad and happy face. So there we go. That's where they will be uploaded to. So the other thing, just conscious of the time because we're going to be kind on time. So the other thing, very popular, first steps, because it doesn't take a huge amount, first steps in a kind of every pun intended, but with just these 5 lines of code, you can turn your microbit with your young learners into a step counter. Very popular project to do. Also starts to introduce variables, so the idea of this box that you can store some information into. I am going to use this project, so the code there for that project is there. I'm going to use this to demonstrate how we download our code onto a device. Okay, so I should have it here somewhere. There we go. So here we've got our code. I'm just going to make it a bit bigger so you can definitely see it's the code. Now, down at the bottom left-hand side, if you're in MakeCode, at the bottom left-hand side, there's a big purple button that says download. I'm just going to move that screen up slightly, and I'll just get rid of that. So what happens when you press download is it comes up with this message. Now, you can, if you want, use web USB. I'm not going to right now, and I generally don't, and I'll explain why, but that is one way for you to flash code directly onto a microbit. I am going to say done because I'm going to do it in a slightly different way. So what's happened is it's put the code down into the little bar that's popped up at the bottom of my browser. And next to that little bar, it's called it's microbit, primary, whatever it's called. There's a little up arrow. And I'm going to press the up arrow and say show in Finder because I'm on a Mac. So that makes this little window pop up. It's given me some code. And what happened here is I don't have a microbit plugged in. Let me just plug in my microbit. So I can already see that I can't see my microbit on the left-hand side. So let me, because I had a camera plugged in, so let me unplug my camera and plug my microbit in. So it should appear somewhere here on the left-hand side in a second. There we go. There's my microbit. And I can just drag my file and drop it on there. Now, the reason I prefer to do that when I'm supporting in the classroom is because I then like to back up. That's the file I can save. So if you directly flash the file, it's not saved anywhere else. So you haven't got a backup. So you do need to download it and have this hex file in your downloads folder just so you can, if you want to store it somewhere else. Like on your OneDrive or whatever. So in the classes that I've been supporting more recently, we've been wanting to back up because we've been building on. So just a caveat on the direct flashing. If you don't need that, you can set that up. And if you've got Chromebooks or iPads, there are links where you can do that as well. So what happened, that obviously showed a little message showing the code going over. If we were on our microbit, it would show a little orange light flashing on the back to say it's got the code. And I'm going to swap over cameras right now. And let's see if this is going to work. Might just take a second. There we go. Let's zoom in a little bit. Oh.
Lorna, Mrs. Dolan's also asking if you could maybe just take them through how to download on an iPad, please.
I don't have an iPad with me, but I can send you a link that has a video that takes you through the process.
Perfect.
So we can do that afterwards. So this is my microbit. and I've downloaded, but I've just flipped it over, so it's already run some of the code. But this was my step counter. So we can see my step counter is currently maybe at number 1. Sometimes difficult on the camera with the LEDs, but if I shake it, it should be a bit more noticeable that it's gone to a 2. I think actually I need to switch the desk light off. That makes it easier. 3, camera 4. So we can see that that one's working with an accelerometer, but clearly my back to front on my camera is moving that around. So that's how we download our code, and then we can take that file anytime we want, and I could then drag that file and put it in my documents if that's where I want to save it, or copy it to. I will send the links to, Brian's already done it. Brian's on fire. Thank you, Brian. So that was a little bit of a whistle-stop tour of some coding to get people started. I'm going to show you some resources also to help you now. Oh, and there is even a video. I might skip playing the video because I'll share the presentation. But again, that talks you through transferring from your computer to your microbit so that you can then unplug it, plug it into a battery and get started. So if I share my screen fully, it doesn't seem to let me still see the chat and stuff like that, which has been useful. So I'm just going to share like this right now.
Can I ask you a controversial question, please?
Go
Mrs. Wilkinson, is iPad or laptop better, Lorna?
Controversial. I mean, for me, the laptop, just because that's what I've used the most. I haven't been in too many schools where they've had many iPads yet, although that's a call out. I'm looking to visit lots of schools, so if anybody wants me to come along, is happy for me to see what you're up to, maybe come and pitch in with an extra pair of hands, please do get in touch. I mean, there's obviously lots and lots of schools that are iPad-only schools, and they get on absolutely fine. So I think it just comes down to personal preference, really. But if anybody has any other specific thoughts, it's definitely something I would be interested in learning about and hearing from other people. But I tend to use a laptop just because the schools that I've spent the most amount of time in tend to be very laptop heavy rather than any iPads.
Thank you. You can't see your face, by the way, but that's okay. I don't know if it's on your visualizer or not.
I just put it down and didn't switch it off, so you got a nice zoomed in bit of the power button there. That was lovely. There we go. So quick covering overview of learning with the microbit. So obviously when you're learning and using the microbit, then there's all sorts of things that you will be learning in and around programming and computational thinking. So algorithms and pattern recognition and iteration, loops, all sorts of things like that. Abstraction, we've talked about inputs and outputs, there's all of that. There's then lots of learning that can take place with some of the projects that are subject-specific stuff, so maybe consolidating knowledge in geography with animating a volcano, or doing some science exploration with conductivity and different bits and pieces like that. What I really want to shout out is this bottom box. This bottom box is the bit that makes my heart happy, and that's all the cross-curricular skills and life skills that you have when you're working and just generally coding, but coding with the microbit. So it's the problem solving, it's like it's not quite doing what I want it to do and figuring it out. The collaboration where they're working together and sharing solutions, being in awe of what somebody else has done and want to learn. The communication that's involved in, how did you make it do that? How did you make it play that song? And then the creativity where they come up with their own ideas and solutions to problems and things that they can do. So it's all of those skills that they kind of learn by stealth because they're having fun that make me really happy. So I just wanted to do a little shout out. We've got a collection here of tips for using microbits in your classroom. I'm going to tell you shortly about the professional development. There is actually a short course on practical tips. So but this is a summary of some of the tips. So making good use of the simulator. You don't have to be sending code to the microbit all the time. There's a real opportunity for that iteration, testing, seeing what different things, experimenting and seeing what things happen. If you added the code to use the accelerometer, so the on shake code, it would give you a little button on the simulator that would allow you to simulate shaking. So nobody needs to pick up a laptop or an iPad and shake it round, but you can still simulate that, emulate that before you take it onto a device. Sharing devices is really good. Paired programming is, a very popular coding technique within the games industry. So, working in pairs and stuff like that and only having one device is not shortchanging them in any way at all. It's actually making them more like real life coders than anything else. So that's great. Think about storage. I think after we had the last session, there was all sorts of great storage ideas shared, and I think we were pulling together some of them onto the course, on the practical tips course. So if you're looking at some ideas there, making sure that there's time for collecting and handing out devices. That's one of the tips that we got recently from teachers, that just making sure that you remember to get them all tidied up together so that the battery packs and the data leads and everything's all together and there's no data leads lying on the floor. The actual device is robust. These have been designed to be touched, used, moved around by little hands. So they are actually very robust. However, it is still a device, and so there's still an opportunity to have that discussion about handling with care, holding at the edges, generally a good thing to do so that you can see the other bits and pieces, but they are generally quite robust. And we're going to look at the microbit classroom in the next session. So just to wrap up, so that you can have plenty of time to go off and enjoy your evening in the sunny or not so sunny weather. There's a few pages I just want to make sure that you're aware of, or a few resources within the Microbit website and Ecosphere. So on the Teach section, which happened alongside the donation, there's computing glossaries, there's guides, there's lessons, there's a whole load of free downloads, so there's planning sheets. So if you have someone who really wants to design an animation, I'm not sure how clear that is, I'm not going to swap cameras again, but there's a whole load of grids so they could design their animation for the grids. There's certificates to celebrate success, there's posters, downloadable versions of the posters if you want more of them. There is all sorts of projects, so there's the project section of the site filled with all sorts of short different projects. Do Your Bit is I need to update that date actually, but Do Your Bit is a competition based in and around the global goals, but actually you can access and use those projects throughout the year, because global goals is a ongoing thing that we should all be thinking about. I just scrolled my mouse all the way through those slides. And then there's professional development. So we've got 8 courses on this website, microbit.thinkific.com. There's 8 courses. They're aimed at getting started with MakeCode. We've got some other courses that will be coming online later on in the year. They are self-directed learning. They sit between 30 minutes to 55 minutes long, depending on what the topic is. It's a mixture of topic introductions and then the practical projects. And the practical projects have a teacher video guide. So it says, here's some ideas of how you would introduce this topic in the class. So the step counter is one of the ones that features. So it talks about how you could introduce what the concept of variables are in the context of a step counter, using a whiteboard and a marker and having people running around so that they understand what variables are before they start coding. And then each project is also supported with a student-facing step-by-step coding video. So if you didn't want to lead the coding as a class activity, you want to be able to work at their own pace there, as some people were at home, or just some people prefer to work alongside a video, and you have that access. And they're accompanied by a workbook that kind of summarises what the content of the course was, what the suggested steps were, and then you get a certificate of completion for each course if you need that for any sort of CPD validation, and these are the courses. So we've got Meet the Tiny Computer, which is an absolute getting started. I've never seen the microbit before, I just want to know what it is. Then there's one on introducing loops, so that's about iteration and repetition. There's animation artists, so using the microbit to do various different animations. Controlling physical systems with sensors is looking at some of the sensors, so making a night light that the lights come on when it gets dark enough. So using sensors to control various outputs. There's gesture and movement, which starts to look at using some of the elements of the accelerometer and how things like tablets and phones work, where as you move the picture around on your phone, it rotates with you. There's networks with radio communication, so we've got a radio feature in the top corner of your microbit, and this allows you to do some basic networking ideas, some basic secured messaging, so a little bit of thinking about what encryption is and how you can send secure or safe messages between one microbit to another. So the radio feature, just for anybody that doesn't realise, I could send something from this microbit and it would be picked up by this microbit. So it's I've done it in a class before when they've been doing a project and we've sent secret messages because we were doing stuff with ciphers and people escaping. I think it was based on a book, and I cannot remember what the book was called at all now. And then there's sensing and making sound, so looking at the sound features, so both in terms of just making music, but also sensing sound. So, you know, can we make a clap counter to sense how many times people have clapped, or you know, how many times there's been a loud noise, or what the level of noise was. And then the practical tips one I've mentioned a few times already. And then generally, if you have any questions, and we've already shared some of the links there, there is a wealth of articles available on support.microbit.org. So you can search there, or you can just get in touch. I'm obviously on here, but you can also get in touch with the team at help@microbit.org. So conscious of not taking up all of your time today because some of you are returners. I'm going to have a quick look. Maybe Louise can tell me if there were any questions. I think there was some good chat going on, so I think Brian solved all the problems or any questions that came up, which is amazing. But if anybody has any questions, feel free to unmute or pop it in the chat. Tomorrow we are going to be looking a little bit more at the sensors and what you can do with the sensors, do some coding in and around them, and then we are all going to join some giant microbit classrooms so that you can see both what it's like from the teacher side, but also what it's like as the student side to participate and share some code, share how happy you are with the code, and have